Have you ever wondered why scientists had to invent a whole new branch of physics, quantum mechanics and relativity, when Newton's laws seem to work just fine? Today I'm diving into the fascinating story of why classical mechanics failed. Let's unravel this turning point in the history of science. For over 200 years, classical mechanics, built on Newton's laws, ruled the world of physics. It could explain the motion of planets, the flight of a cannonball, or why an apple falls to the ground. Everything seemed predictable, calculable, and orderly. So what went wrong? As the 19th century ended, physicists started noticing that classical mechanics couldn't explain some very important observations. Let's break these down. First up, black body radiation. Classical physics predicted that a heated object should emit infinite energy at high frequencies, especially ultraviolet. This was called the ultraviolet catastrophe. But in real life that didn't happen. Classical mechanics failed here. It was Max Planck who stepped in and said, "What if energy is not continuous but comes in small packets called quanta?" Boom! Quantum theory was born. Then came the photoelectric effect. According to classical wave theory, light's energy depends on its intensity. But experiments showed that even low-intensity, high-frequency light could eject electrons, while intense, low-frequency light couldn't. Strange, right? Einstein explained this by saying, "Light is made of particles, photons, and their energy depends on frequency, not intensity." Again, classical physics failed. Next, classical physics couldn't explain atomic stability. According to classical electrodynamics, an electron orbiting a nucleus should spiral inward and crash. But atoms are stable. Niels Bohr introduced quantized orbits, where electrons could only exist in certain energy levels. This explained atomic stability, but it needed quantum ideas again. And let's not forget Mercury. Its orbit kept shifting slightly, something Newtonian mechanics couldn't explain. Einstein's general theory of relativity nailed it. Turns out Newton's gravity was an approximation. Einstein showed that gravity is the warping of spacetime, something classical mechanics never imagined. So, to sum it up, classical mechanics failed because 1. It couldn't explain atomic and subatomic phenomena. 1. It broke down at very high speeds, close to the speed of light. 1. It didn't work for very small particles. 1. It failed to explain certain astronomical observations. But here's the thing. Classical mechanics isn't wrong. It's still incredibly useful for everyday physics. But just like a map of your neighborhood doesn't show the whole world, Newton's laws couldn't explain the full reality of the universe. Pause and smile. And that's why we needed something beyond quantum mechanics and relativity. The revolution that changed science forever. Thanks for watching. If you found this interesting, don't forget to like, share, and follow for more mind-blowing science stories.